In the quantum world, particles don't behave as we expect. An electron can exist in two places at once. A photon can travel down two paths simultaneously, and the universe, at its deepest level, refuses to make up its mind until we look. This is the superposition principle, a rule so strange, so beautiful, and so powerful. It defines the very heart of quantum mechanics. It's the reason atoms form, why stars shine, and why the act of observation may be the most mysterious force in the universe. Before we get too deep into this topic, be sure to like this video and subscribe to the channel. This helps to bring more valuable content to the platform for your knowledge and understanding. Remember, knowledge is power. Now back to the episode. The story begins at the dawn of the 20th century. Physicists were grappling with paradoxes classical physics couldn't explain. Light behaved both like a wave and a particle. Electrons, tiny bits of matter, showed wave patterns when no one was watching, yet acted like solid particles when observed. In 1926, Erwin Schrödinger introduced a new way of seeing reality. He proposed that particles weren't objects at all, but waves of probability. His equation didn't tell us where a particle is, it told us where it might be. And that probability, those infinite possibilities, exist all at once, in a state of superposition, until measurement collapses it into one outcome. To expose the strangeness of this principle, Schrödinger imagined a cat sealed inside a box. Inside, a vial of poison is triggered by a quantum event, a decaying atom. If the atom decays, the cat dies. If not, the cat lives. According to quantum physics, until the box is opened, the atom exists in both states, decayed and undecayed, which means the cat is simultaneously alive and dead. It's absurd, yet mathematically consistent. The superposition principle says that every possible outcome exists, until consciousness forces the universe to decide. In quantum mechanics, we describe a system using a wave function, often denoted as psi. Psi contains all possible states of that system, its position, momentum, energy, all encoded in complex amplitudes. When two or more quantum states overlap, their amplitudes add together. This linear combination creates interference patterns, constructive where waves align, destructive where they cancel. This is the essence of superposition. A particle can exist as a blend of multiple states, each one real, each one contributing to the whole. It's not a trick of perception, it's the fundamental nature of reality. Nothing demonstrates superposition more vividly than the double-slit experiment. When a beam of electrons is fired at two slits, an interference pattern emerges, as if each electron passes through both slits simultaneously. But the moment we measure which slit it passes through, the interference vanishes. The wave of probabilities collapses into a single path. Observation doesn't just reveal reality, it creates it. This experiment shattered our classical understanding of the universe. It showed that superposition isn't confined to the subatomic world, it's woven into the fabric of everything. When two particles interact, their quantum states can become linked, a phenomenon called entanglement. From that moment on, they share a unified wave function, existing in a joint superposition no matter how far apart they are. Measure one, and the other instantly takes on a complementary state. Einstein called this spooky action at a distance, but experiments have confirmed it again and again. Entanglement is superposition on a cosmic scale, stretching across space, defying locality, hinting that information itself might be the true substrate of reality. Far from theoretical, superposition is revolutionizing technology. In quantum computing, qubits can exist as 0, 1, or both simultaneously. This allows them to process vast amounts of information in parallel, achieving exponential speedups classical computers could never match. Quantum sensors exploit superposition to measure gravitational waves, detect magnetic fields, and map the brain with incredible precision. And in quantum cryptography, the collapse of superposed states ensures unbreakable security, because any eavesdropping changes the data itself. Superposition isn't just abstract, it's engineering the future. But what does this mean for us, for consciousness, choice, and existence itself? If every particle exists in a superposition until observed, then what is an observer? Are we collapsing reality merely by being aware? Or are we ourselves quantum systems, our consciousness an emergent property of entangled neurons, suspended in countless overlapping states? The many worlds interpretation suggests that superpositions never truly collapse. Instead, every possibility becomes real, in parallel universes that diverge with each quantum decision. In one world, the cat lives. In another, it dies. And in countless others, both outcomes continue to exist. Superposition might not just describe particles, it may describe reality itself. Modern cosmology suggests that the entire universe began in a quantum superposition, fluctuations in the quantum vacuum giving rise to galaxies, stars, and life itself. At every level, from subatomic particles to cosmic structures, the universe remains a tapestry of overlapping probabilities. Even you, your choices, your thoughts, your potential, exist in a quantum field of infinite possibility. To observe is to choose. To decide is to collapse a universe of potential into a single path. The superposition principle challenges us to rethink everything we know about reality. It blurs the line between matter and energy, between potential and existence, between dream and observation. In the quantum world, certainty doesn't exist, only possibility. And perhaps that's the most profound lesson of all, that every moment of our lives exists as a superposition of infinite futures, waiting for us to decide which one becomes real. If you found this content helpful, don't forget to like this video and subscribe to the channel. Leave me a comment. Let me know what you think about the superposition principle. I'll see you next time for another deep dive into the strange and unusual world of quantum physics.